Hey guys, let's do some more practice on graphing linear equations. So I'm just trying to pick ones that maybe are a little bit harder because they're written differently or they involve fractions. So we're going to take a look on this video at these two right here, and then we'll come back and look at two more. So the first one we have is 5 minus 2x, y equals 5 minus 2x. So if you look back at the ones that we've already done, you'll probably notice that in the other problems, the x term comes first and then the constant terms comes second. So this is just a little bit unusual then in how it's written, but it's still okay. We can do it. So just like before, I'm going to pick some values here. I'm going to go with -2, -1, 0, 1, 2, just to give us some positive values, some negative values, and 0 is always a nice easy one to have in there. All right, so this is saying that the y value that goes along with -2, or any of them really, is 5 minus twice the value that's given. All right, so we're going to do 5 minus twice the value that's given. The value that's given is -2. So there's a couple different ways we can do this. One is we could just look at 2 times -2 and say that's -4. So then we're going to do 5 minus, because again, that wasn't part of what we were doing, -4. All right, if we do 5 minus -4, remember we do keep, change, change. That's going to change this to a positive sign, and that's going to change the negative to a positive. And so we get 5 plus 4 is 9. If we choose to do that way, then each time we're going to have to do keep, change, change. The other way we could do is just right at the beginning say, I'm going to rewrite this as 5, and I'm going to change the subtraction to addition, and I'm going to change this to -2 times the value that's given. And then we won't have to change it every time. So it's entirely up to you. Either change it every time you do it, or you change it once at the beginning. It's up to you. I am going to go this way because I don't like to do the same thing over and over again where I would have to always change to add the opposite. So I'm just going to do it this one time at the beginning and then always write it using this form. So this next one is -1. I'm going to do 5 plus, because I'm using this one, -2 times -1. Right? I do the multiplication first because of order of operations. -2 times -1 is +2. So this becomes 5 plus 2, which is 7. The next one is going to be 5 plus -2 times 0. Anything times 0 is 0, so this is 5 plus 0. I get 5. This is 5 plus -2 times 1. -2 times 1 is -2, so this is 5 plus -2. 5 plus -2 is 3. Again, you could probably be looking at this and say, I could guess that this next one's going to be 1 because I'm looking and each time it's decreasing by 2. Right, so, but let's just do it to verify. It's 5 plus -2 times regular 2, so this becomes 5 plus -4, which is in fact 1. Okay, so now let's graph it. And again, since I'm making my own graph here, I'm going to try and be smart about this. I know that I have to space my x values out half to the left of the y-axis and half to the right, but all my y values end up being positive. Right, so I'm going to choose to do my x-axis down low like this so that I have plenty of room for all these y values that I have. Again, you could choose to just always do it in the center, that's fine, but I'm going to choose to kind of be smart here so I don't have a lot of wasted space. And I'm going to put my 1, 2 to the right and 1, 2 to the left. And then up here I've got to fit 9, so I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9. I could have done them a little bit bigger. 1, 2, 3, 4, 5 is right here. And again, notice how, and we talked about this in the last video, my x-axis values are about a pencil point away, maybe a little bit bigger, or not a pencil point, a pencil width away, but here it's much closer. And again, that's because I have a lot more to fit on here, so I don't want to have to do them the same width and end up running all the way up here. Okay, so we plot them. So the first point says -2 on the x, 9 on the y. So from the origin over to the -2, up to the 9. Next point says -1, 7. Next one says 0, 5. Next one says 1, 3. And then the last one says 2, 1. And again, we're going to connect the dots. And again, it continues on forever in both directions there, both up in the left direction and down in the right direction. So I'm not gonna stop and only draw this much of it, because it doesn't just stop there, it continues on forever. So I'm gonna continue it and draw arrows on the end to indicate it continues forever. Okay, now if you're thinking about some of the questions I asked you in the last videos on Tuesday, then we could kind of pay attention here to say, why does it go down as we read from left to right? And what is the pattern? So again, here I'm noticing that for my x's, every time I increase by 1, which is what I've done here, increase by 1, increase by 1, increase by 1, what happens in the y values? And you should notice that it decreases by 2, decreases by 2, decreases by 2, decreases by 2. And then the other question I asked you was, where does it hit the y-axis? Where does our graph hit the y-axis? And right here it hits it at y equals 5. And so again, my question to you is to just, or my hope for you is that you'll kind of be saving all of these things in your mind and looking for patterns, so that when we start talking about specifically what these mean, you'll kind of have an idea because you've made an educated guess. So does that 5 show up somewhere in the equation? Does this downward thing happen to certain types of equations that this also has in it? Do we notice a pattern with these related to our equation? Okay, next one. Y equals -3/4 x plus 1. So we saw one like this last time. It was a 1/2 here, and it was positive, not negative. But the question that I had for you, or the comment I had for you was, let's be smart. Let's not pick -2, -1, 0, 1, 2, because I don't want to end up with a fraction here. All right, when I multiply the 3/4 or the -3/4 times the x value I've chosen, I don't want to have to deal with fractions. So let's be smart about it. All right, so I'm going to pick x and y. I'm going to pick 0. -3/4 times 0 is just going to give us 0 there, so that will not give us a fraction. So if you remember, think about this for a second before I fill in the values. What values could we multiply 3/4 by so that the 4 in here will cancel out with the x value and we end up with no fraction? Right, so if you said -4 and +4, you would be correct. We could also do -8 and +8, because if we have 3/4 times 8 over 1, sorry, I'm just realizing I'm not in the screen here, 3/4 times 8 over 1, this 4 will cancel out with this 8, and we would have 3 times 2 is 6. So 8, negative and positive would also work. All right, so let's do that. We may end up not wanting to graph those. I'm not sure if they'll end up being too big, but let's just try it. So the y value that goes with -8 is going to be -3/4 times -8. I'm going to write that as -8 over 1. Sorry, I've got erasers under here. And then plus 1. All right, so negative times negative is going to give me a positive. And then I'm going to cancel out here first. 1 and 2. So this is -3 times -2, which is +6, plus 1 is 7. Again, those negatives are the spot where I feel like you're going to make your mistakes, so just be really careful with them. All right, next one says -3/4 times -4 over 1 plus 1. This 4 here will cancel out with this. right? So then we're going to have negative 3 times negative 1. That is positive 3 plus 1 is 4. Negative 3/4 times 0. We love multiplying by 0. Negative 3/4 times 0. Anything times 0 is 0. So then this is just 0 plus 1. And again, remember, 0 times a negative number, it doesn't make it a negative 0. There is no such thing as a negative 0. It's just 0. 0 plus 1 is 1. Then we've got negative 3/4 times positive 4 over 1 plus 1. These cancel out. So we've got negative 3 times positive 1. Again, negative times a positive gives us negative, so that's negative 3 plus 1 is negative 2. And then finally we've got negative 3/4 times 8 over 1. That cancels. We have negative 3 times positive 2. Whoops, I forgot the plus 1. That's negative 6 plus 1 is negative 5. All right, so we've got a lot of variation on the x values. It's not nice and close like these are. We're actually going to be spread out pretty far on the x-axis. And then we've also got about equally spaced above the x-axis on the positive y part, and then below the x-axis on the negative y part. So this one would be a good one to do pretty centrally, have the vertex pretty centrally, not vertex, sorry, origin pretty centrally located. And then I'm going to do these really tiny so I don't go out too far. So 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. So let's go negative 4, negative 8, positive 4, positive 8. And then 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7. Okay, let's graph. This one says, starting at the origin, we go over left to the 8, the negative 8, and then up to 7. Next we go over to negative 4 and up to 4, which is right here. Then we go over 0 and up 1. Then we go over 4 and down 2. Then we go over 8 and down 5. 1, 2, 3, 4, 5. And that is our graph. All right, so again, as we read from left to right, it's going down. Are you surprised by that? Have you figured out a pattern here? And then here, as we increase by 4, negative 8 to negative 4 is 4, negative 4 to 0 is 4, 0 to 4 is 4, 4 to 8 is 4. Here we decrease by 3. All right, and the place that we cross the y-axis is at y equals 1. Okay, we're going to come back and do 2 more in just a second.